to the next question that we have on the menu today. The next question that we have on the menu today is, what is the area of a semicircle? Now first, we got to think about something. What is a semicircle? Here we have a circle. I'll try to have a straight line. Chop that circle in half and you get a semicircle. I'll just color in the part that we're trying to figure out. Okay, so that's semicircle. Beautiful. So we got to find that area. So, what would be an easy way to think about this? I already mentioned a semicircle is just a regular circle chopped in half. So would it be reasonable to then say that area of semicircle equals area of circle divided by 2? That sounds about right. If we had the whole area, divided that in half, we'd get the area of half of it. So that'd be the area of the semicircle. That's cool. Cool. So let's rewrite area of a circle. That's one of those trusty equations that you're probably going to need to remember. And you're going to know that it is pi r squared. And we got to keep the divide by 2. Now, what is r? R, radius of circle. Now, what is the radius? The radius is, hey, it kind of looks like a Pokeball. The radius is the distance between the center of the circle and the edge of the circle. And radius is the same no matter which direction it is. Like the radius here, the radius there, always the same radius. So if we have the radius, we could figure out the area. So let's make this, let's call that AOS, area of semicircle, is equal to pi r squared over 2. But let's say that our semicircle, let's see if I can draw one actually. Okay, looks like I'll have to draw it by hand. Let's say we get a semicircle, someone gives us half a pizza or something like that. Or like, someone cuts your skateboard wheel in 2. And you can only figure out here. You can only figure out that. That is called the diameter. And sometimes with circular type things, it is easier to measure the diameter than it is to measure the radius. An example of that is like, let's say you have a cup, the opening of a cup. Diameter, you measure like, okay, the side to side length. To measure the radius directly, that's a little bit more difficult because you got to be like, okay, I have to find the perfect center of like, the opening of the cup. The distance from the perfect center to the edge, that's going to be the radius. Well, it's difficult to find out exactly where the perfect center is. So in some applications, finding the radius, the diameter instead of the radius is going to be easier. So, hey, wait a minute. If we know that that's the center, and that's r, that should be r as well. So we know that diameter is equal to d, but it's also like d just as a symbol because we don't want to be writing out diameter every time. D as a symbol, diameter, is equal to 2 times radius. Interesting. So let's see if we can input that into here so that we have a different equation that can help us if we're only able to find the diameter. And there are some real world reasons why that may be the case. So we can use the same equation, like we got pi over 2 multiplied by, let's isolate r from here. So R is equal to 1/2 diameter. So we'd have 1/2 diameter in here, taking the place of where R used to be. But R is squared. So this entire unit, 1/2 D, needs to be squared. Okay, let's expand that out. We got pi over 2 multiplied by 1/2 D squared is the same as D squared over 2. Over 4. 4 being 2 squared. So basically you're just like, okay, squaring the top, so that's the D squared, and then you square the bottom, the 2 squared becomes a 4. Okay, so let's compress this even more. Like we can multiply the 2 and the 4 on the denominator together, so we can get pi times D squared divided by 8. That is equal to pi times radius squared divided by 2, which is the area of the semicircle. Pi, by the way, if you're unfamiliar, is 3.1415926, and it goes on and on. It doesn't really make that much sense for you to memorize more than like 5 digits of this, because normally you're going to be using your calculators anyway to get this number. But just for your reference, if you don't have a pi button on your calculator, you can you're typically good with just going with like 3.14 typically. But yeah, that would be exactly how we find the area of a semicircle. And it would seem that the solution that we have here on OneClass definitely agrees with us. So we can verify that. The above question is, or the above is correct. Cool. Let's clear this out. And let's get it moving to the next.